Digger, I'm going to start now.
Okay.
The average was quite a bit better on Schoology than on Big Ideas Math. I know one reason for that is because it was multiple choice and true false and not fill in the blank. But I also just think the grading on Big Ideas Math when you do fill in the blank is difficult because some of you guys were getting answers that were very close to the solution and getting it marked wrong. So anyway, I feel a lot better about what happened on Schoology. What about you guys? You feel like it was better, right?
This is way better.
So I'm looking at maybe like a hybrid, maybe like a Schoology and then just like a couple questions on paper or doing something to mix the two. But I just think, man, those tests and quizzes that are just on Big Ideas Math, the averages are always like lower than I think they should be. And I know that's frustrating for both you and me. So anyway, I'm still working it out. Today we're focusing on science.
What?
Well,
I had 2 science classes today. My 3rd science today. Yeah, no, not at all. I have 2 science classes that day.
all right. Anyway, sorry, I shouldn't have said that. The classes in science. What I mean is, okay, so we're working on about straight lines, right? Well, starting right now, the end of chapter 4 is scatter plots, where you draw a straight line through the data and you write an equation for that line. So we're still looking at point slope form, slope intercept form, but it's looking at data that scientists have collected. So I hope you've taken a moment to take a look. What is this all about? You're doing a quiz, right? On Schoology. Go to this course and find the age that. Yes, age of a first marriage. Age of a first marriage on average. Well, there's one statement. So your goal is to write 2 statements. Just look at it, and you can. I'm interested. Like something that you observe is probably different than something that somebody else observes. So make 2 observations, any 2 statements you want about the data shown in the graph. Got a little joker out there. What are you gonna write, Jigga? What are you gonna write? What are you gonna write?
Both of them are ascending.
Both of them are ascending. What a great math and science word. Ascending means going up. They're both going up. But what's going up? Let's try and say that. Take your feet off of this. You piss me off. Okay, so let's go ahead and define. I love Jagar's observation. Let's make it even more precise. He says both of them are ascending. Let's just add details to that sentence. So what's the sentence is the age people tend to get married and they gradually older yes, as time has gone on. It starts in 1960. Your parents, yeah, we're talking your grandparents' days. Maybe they got married in their 20s. And then in the 80s, people are getting a little bit older. In the 2000s, I'm lost. Your parents probably got married between 2000 and 2010 if they're married. And they were in their late 20s. And now we're really approaching 30 for one of the genders. Melina, which gender in the year 2015 is approaching 30 Yeah, males. So, the first observation was that both are going up over time. The age people are getting married is increasing. I'll write that.
The first dot is above 20, but underneath 22, so that's like 20 and a half. How do you have half of the age? Like the fourth the fourth dot is 21. The fifth dot is 22. What's the sixth dot? How old are you right now? How old are you right now? How old are you right now?
Yes, people don't have a birthday every day, so there's an entire year in between there, man.
You have time. What?
There's a lot of time between there. It's a whole year. Okay.
My bad.
Over time, the age people get married is descending, and then our second observation, I started talking about gender. It looks like the age that men get married, just about 2 years older on average than women. And you can make any observation you want. What's cool to observe is that hasn't changed. Like the age gap between men and women, even though like women are waiting longer to get married, like the men they're marrying are still 2 years older. It's kind of weird, right?
Very.
Like you would think at one point, like the women and then the men are staying the same and they meet up, but no. So let's stay on track.
Mind your business.
Can be married 2 years later. Yes, you can. Yes, you can. Okay, so
Say that's a little much.
alright, so anyway, to introduce this new topic about collecting data and analyzing data, we are gonna watch a short video made by your textbook company. It's a 6-minute scientist video. And then I'm gonna be asking you more questions about scatter plots. So just get ready. Every time I do cheerleader.
Depending on where we're working, we sometimes set up tents and live out in the tundra for weeks at a time. And some of the coldest field trips I've been on were in Alaska, but right across the ocean from Siberia. And it would drop down to minus 30, and we were sleeping in our sleeping bags with nothing but our breathing holes of our noses showing. And you never expose any skin, but you just keep moving or huddle.
I just remembered, I wanted to tell you what this is about. This scientist, you guys have heard about how the glaciers are melting? Well, she's studying the dirt underneath the glaciers. So the glaciers that are or the dirt under it is exposing all these fossils that we haven't had a chance to study because the modern human era has had that, it's been under, layers and layers of ice. We haven't been able to get to it. So now there's this whole piece of history that we can go and collect and find because it's exposed. So there's a lot of information we can figure out now that that ice is melting away.
Pull down your sleeping bag and get the work done. My name is Katie Walter Anthony. I am a limnologist and a National Geographic explorer. A limnologist is a scientist that studies fresh water. Most of the lakes that I study are in the Arctic. And in the Arctic, we have a lot of frozen ground, otherwise known as permafrost. And as that permafrost thaws, the frozen soils thaw out beneath the lake. And microbes decompose the organic matter. They decompose the remains of animals and plants that died tens of thousands of years ago. And they produce greenhouse gases. Methane is one of the greenhouse gases. It's a very potent greenhouse gas, about 30 times stronger than carbon dioxide in its global warming potential. So I study how much methane is released from lakes in the Arctic. And if you were to fly over the Arctic and look out the window of the airplane, you would see that there are millions of lakes across the Arctic. And each of those lakes is burping out methane. And it does that in the form of bubbles. And so when I go out to these lakes, I'm looking for bubbles. So it happens around the whole world. But there are so many lakes in the Arctic. And they have an extra special food source, which is this permafrost, these frozen soils that are thawing today. So in the Arctic and some of the lakes where I work, if we went back in time to the last ice age, so 20,000 years ago, 40,000 years ago, when massive ice sheets covered a lot of North America and Europe, there were pockets of Siberia and Alaska that were not glaciated. And that non-glaciated place was a refugium. It was an environment where the mammoths and the woolly rhinos and the Pleistocene lions could live. And so when all those grasses and animals died, their bodies got buried in the soil and they froze in place with very little decomposition that happened during that cold period in history. So the dead plant and animal remains have been locked away since the last ice age. And today, when a lake forms, the water in the lake actually heats up the ground and it causes the ground to thaw. And so that's the remains of those dead plant animals become food for microbes, decompose them, and generate greenhouse gases. So I go out to the lakes and I look for bubbles and I have bubble traps and I put these bubble traps, they're kind of like underwater funnels in the lake and the bubbles come into them so I can trap the bubbles. Well, and then in all that cold, my job is to sample the bubbles. And so I would get up out of my sleeping bag, get dressed as fast as I could. Sometimes I did not even change my clothes. I just took layers on and off. And then go out to the lakes carrying an ice spear and my bubble traps and a shovel. And I would go out to the lakes and open a hole in the ice. And then I'd have to pull my bubble trap up. And if there was gas to sample it, I actually had to strip down into bare hands and stick my hands and arms into that icy cold water, which wasn't bad because the water was actually warmer than the air. What was really painful was pulling your hands back out of the water, and my neoprene gloves would freeze solid, and it was hard to even get my hands out of them at that point. And I could take the samples of the bubbles into little glass vials and bring them to the laboratory, and I study how much methane is in the bottles and carbon dioxide. And when we take the methane out of the bottles, a methane is a carbon with 4 hydrogens. In the laboratory, we can strip off the hydrogens so that we have pure carbon now. And pure carbon is graphite. So it actually turns from a gas that's invisible and feels like it weighs nothing into a little piece of graphite in your hand that's pure carbon. And it's the exact same carbon atoms that were in the bubbles, which also originated from the dead ice age animals. So that's how we're linking the bubbling that we're seeing today to the Earth's ability to store carbon away in a freezer during the ice age. And today, in a warmer climate and in an ever warming climate, that freezer door is opening. More of that frozen carbon is thawing out and becoming food for microbes, which release greenhouse gases. And if you put more greenhouse gases into the atmosphere, it causes more warming and more thaw, and we get what's called a positive feedback loop to climate warming. Now, as a scientist, I use math every day. I don't even think about it. It's a natural part of being a scientist, and it makes so much sense when I'm using it because there's a question that I need to answer. So some of the ways I use math is to go out to the frozen soils and dig or drill a pit and collect soil samples and measure how much carbon is there. And then I add up the carbon on all the different layers so I can see how much carbon is frozen away in permafrost. When I collect the methane bubbles, I have to know how many of each type of bubbles there are in the lake ice. Once we have quantified how much methane is escaping from these lakes, how much carbon is in the permafrost, how much can thaw in the future, all of that goes into mathematical models so that we can translate this amount of methane that's entering the atmosphere into an increase in the Earth's temperature as that methane is released, because when that enters a greenhouse gas, it causes the surface of the Earth to warm. My name is Katie Walter Anthony. I'm a limnologist and a National Geographic explorer. And I use math in my science work every day.
So it turns out that one of the biggest contributors to global warming is just the soil. That soil, when it gets warm and all the things that are in there get released from it. And how do you stop like soil, right? So, but now that they're acknowledging that, there probably is something you can do to maybe you can put something in that soil that consumes carbon, or I have no idea, but kind of a neat idea. But do what with it? There's like they're saying like the carbon gets released and that's the methane gas, but what if we just go back and rebond it with hydrogen and turn it back into some water form and then store that liquid somewhere else? I think like big engineering ideas like that, where you like there's certain you guys have heard about like coral reef is disappearing, like the water's getting too hot and like the colorful coral reef is just like dying away. You've heard of that. And what are they doing to counter that? They're just like putting concrete back into water so that algae builds on it and then that attracts fish and then other things start to grow. So in order to counter the loss of coral reefs, we're building coral reefs other places. I think they're doing it right off the skyway. They're putting things in there to start the growth of other things to make it a good natural organic environment. So once there's a problem, humans are pretty good at figuring out solutions. But they got to know the problem and really understand it. So let's get someone is studying all that methane. What are we going to do with it? Someone's going to think of something. That's what I count on. Maybe one of you guys. We're counting on you guys to figure that out. All right. Head to page 347. We're going to look at another type of data. We're going to read this data about smoothies and calories and sugar. So our first example was about marriage and age. That's like sociology. We just watched a video about methane and geology. And now we're looking at biology at sugar and calories. So the idea here is pretty much in every form of our human science, you collect data. And the better we all are, even if we're not scientists, at reading and understanding that data, the more informed we are as citizens. So y'all, you're going to go ahead and you're going to read this and you're going to try to answer 1 through 3 in this gray box right below it. Calories, sugar, and smoothies. Biology. So, what are your two favorite subjects like science and math? I really love history. I really love history. So I can't say that. I would really like to like study it, like the history of math and who came up with it and when. But well, lots of people came up with it, but a lot of our math is contributed to the Arabic civilizations, the Middle East, also Asia, and China. So a lot of math. Anyway, I like all of math. I generally enjoy school. So yeah. That's my yeah, and James gets that. I didn't really like English class that much. I thought it was incredibly boring.
It is.
I just thought it was so boring.
It's too much.
Shut up. Well, I don't know what's the name all the time. Yes. All right. I got tricked into answering a question. I'm gonna be quiet.
You get tricked into answering it.
Just go ahead and do number 1. I think you're capable of it. Actually, I want you to do these gray box ones. But do you have the pages there? And you still got to put them in the binder? You just put them in there, yeah? I see people starting to write. What about you? Look, you were here yesterday. Do you have a question or an answer or what? Well, number 1 says how many calories are in the smoothie that contains 51 grams of sugar. So it doesn't matter. You can look at this one or this one. Oh, I'm just realizing that I drew this in here. So we're looking for 51 grams of sugar. Sugar is on the x-axis. 51's about right here. Because this is going by 4. So 1, 2, 3, 4. So when I go up, looks about like 260. You did? I think that's 52. 53, 54. Approximately 260 grams. How many grams are in the smoothie that contains 250 calories? So this is flipping your focus. Instead of looking at sugar, you're looking at calories.
50 cents. 50 cents.
Approximately 52 grams. Another point, 55 to 80 is plotted on the graph. Explain the meeting. So write a whole sentence for that one. Who wants to do the sentence? Ashley, you want to do it? Yeah, actually put the numbers 55 and 280 in it.
They got hair on it. Might as well just go ahead and drop it.
There are 55 grams of sugar in a smoothie that is 280 calories. What's easiest to see when you look at a food label? What do you see more quickly, the calories or the sugar? The calories is a great big number at the top. Usually it's bigger. And so this is saying if it says 280, there's probably about 50 grams of sugar in there. It's like a proportionate relationship. Assess their reasonableness. Do you think it is possible for a smoothie to be represented by a point on the y-axis? Okay, this is a cool question, actually, you guys. Let me ask you this. I'm going to do a big red dot right here. Is it possible that a smoothie would be right there? Oh, okay. I labeled that. Alright, what do you guys think about my big red dad? Is that even possible in the world of smoothies and calories? Are there any 0 sugar smoothies? There are. What are they? What's in a 0 sugar smoothie?
Water.
Aspartame. Splenda. Aspartame.
It's a natural.
Nutri-Sweet. Sugarlight. Sugarlose. It's pretty much like a diet soda. Something other than sugar, making it taste sweet. So yes, 0 sugar grams is possible, but there's a lot of science against those fake sugars. There's a lot of science that says those fake sugars, aspartame things, they're having bad effects on our body. The more we introduce them into our food, the more things are showing up that aren't good for us. Yes, but normally, like anybody who's like advertising a 0 sugar smoothie, there's a fake sugar in it using artificial sweetener like aspartame. I'm gonna go with artificial sweetener real quick. Artificial sweetener. That's not even 0 sugar grams is possible using artificial sweetener. And that's just a diet soda or whatever. Melina, can you not? No, Tavis, you're in the middle of something. Don't even get in it. Okay, let's move on. All right, turn the page. This is something I believe you're already aware of. Correlation, positive, negative, and no correlation. I believe you've been taught this before. Am I right? You've been taught this. So let's move on away from it. This is what I really want to do here on page 350.
Instead of being on your phone.
Page 350, guys. All right, now we're talking business, marketing, profit, sales. The table shows the gross revenue in millions of dollars for a movie each week since its release. There's lots of talk about movies, and if they're still making money, they cost a lot of money to produce, and people really aren't going to the theater as much as they used to. So there's a lot of business talk. We need to write an equation that models the revenue, interpret the slope, and intercepts the line of fit. So we're going to make a scatter plot. We're going to plot these points. All right, down here is weeks. It's going to go 0, 1, 2, 3, 4. Yep, all the way to 8. The y-axis is gross revenue. That's as much money as the people got for putting their movie out. And it's revenue in millions. So how am I going to do this? It ranges from 8 to 135. If we go by tens, 10, 20, 30, 40, 50, 60, 70, 80, I think it's a 90. Should we go by 20s? Yeah, I'm just going to go all the way up. I'm just going to keep going. I'm going to make this bigger, guys, and go by tens. 10 million, 20 million, 30 million, 40, 50 million, 60, 70, 80, 90, $100 million. 110, 120, 130, $140 million. All right, now we have to plot this data. So in week 1, they brought in $135 million. Pretty good job. It's a Marvel movie. We're talking whatever Marvel is. I don't even know. Okay. Week 2, they brought in $110 million. It's a movie. Week 3, $77 million. Week 4, $65 million. Week 5, in half, we're down to $34 million. Week 6, $21 million. Week 7, $14. Week 8, $8 million. So that makes sense. Over time, less people. Everyone who really wanted to see it, they saw it the first week it came out, and then 2 months later, it's like, yeah, it was good. Let's go see it again. I don't know. Okay, so it's to write an equation. So how are we gonna write an equation? It's like all over the place. What we're gonna do is we're gonna draw a line of best fit, and there's some rules about lines of best fit. First up, you want to use a ruler or just like the side of your ID to make it a really nice straight line. But a line of fit goes through the data. I do want to put like kind of a disclaimer. This does not connect the dots. Do not connect the dots. Do not connect every dot. Yeah, we don't want a zigzag line. We're looking for one clean straight line. So it goes through the data. You want to aim for the same number of points above the line as below the line. Let me see how they did their line of fit up here. You guys, let's count this one that the book did. This is about website subscribers. Let's see. They got about 3 underneath their line, 3 dots below it, and they got 1, 2, 3 above. That's kind of what you want. Okay, you want to be through. Notice they did not zigzag and connect all these dots. It's a line through the data. You want some above and some below. So when I do it, I often have to erase and try more than once. So you're just gonna set up your ID if you plotted your own point. It would be great if it was all like right in their favor, but it's not. This is my this doesn't look straight. I'm gonna try again. What do you guys think about this line? Does it go through the points? It does not connect the dots. I'm going to count how many I got above and how many I got below. I got 1, 2, 3 above, 1, 2, 3 on the other side. So I'm going to accept this line of fit. Your line is going to look a little bit different than mine. If 30 of us make a line, we're going to have 30 different lines, and that's okay. All right? So go ahead and make your line, guys. After you make your line, you're going to pick 2 points to do slope formula. And you're going to write an equation of your line.
But if the dots don't line up, then it's not a linear equation.
If what?
Like,
yeah, right. Exactly. He said if the lines don't line up, it's not a linear equation.
So how would you calculate the slope of a non-linear equation?
That's why we put a line through it. That's what the line of fit is. Once I have this yellow line, I'm now ignoring the red data and I'm focusing on the trend. It's a trend line. Okay?
That makes more sense.
Good comment. Really good. So, okay, make scatter plot. That was my first objective. Check. Draw trend line. Check. Next, you pick any 2 points on the line for a slope formula. So this is really difficult for teachers to grade because the points I pick are going to be different than the points you guys pick. When I grade this, I have to pick all of your points separately because I'm telling you, you can pick any 2 points here. So if you guys want to do this one with me, I'll tell you I'm going to pick this right here, which is at 6:30. And I'm going to pick this one right here, which is at 5:50. And now I'm doing everything that we've been working on this whole chapter. I'm doing slope formula. And then I'm doing point slope form. And I'm making an equation for this line through this data. And this is really how scientists do it, guys, because real data that's collected, it doesn't fall on a perfect line. So they draw a line through it and they make a line. And actually it's software and programming that makes it perfectly. It's called linear regression. And when you get into statistics, you learn how to do it perfectly so that we all have the same equation and things. But this is just the intro to that.
That's an angry computer thing called linear regression.
Regression.
Oh, I thought you said aggression.
And like what it means is that we measure the distance between the red points to the yellow line. How far does it like regress from the line? And then we give that line a score. Is this line close to data or is it far from data? A correlation score. And then we know how reliable our line is. And that's how scientists are putting information out there.
Okay, that makes sense.
Okay, so I got 30 minus 50 over 6 minus 5. And this means that each week the movie grosses about $20 million less. 20 million or 200 million? Yeah, each week. Do you guys know what gross is?
Notifications on.
All right, so my slope tells me each week they're making 20. Do I have to write a whole line? Yep, I got to write a whole line. So I've interpreted my slope. My slope is negative 20. It's too bad. Every week my movie's making $20 million less.
You losing your money. So how do you feel about losing your money? That's my question.
Alright, so, okay, I still have to write the equation, and then I have a business model, and then I know how much I really want to pay Netflix to keep showing my movie. Okay, so when do I want to release my movie on a Netflix? Well, probably when I start making $0. But Netflix is like, but if you do it a month sooner, then you're going to have more watchers because they're still excited to see it, and then they're analyzing all of these different lines, the lines that Netflix shows them they're going to make versus the lines of this the theaters telling them how much less they're making each week. And that's how they make business choices. Yeah, we gotta make good choices. They're not just willy-nilly putting it out there. They're looking at real numbers. Rely,
That's-
rely on
that's-
math next time. Rely on math and look at the data.
Yeah, you have to count them calculations. You have to do them calculations. These calculations you use question very fast.
Okay, y minus 30 equals negative 20x plus 120. Add 30. Y equals negative 20x plus 150. This is claiming my math. Let's see if my math looks like the same as my graph. Is my y-intercept at 1